This is a continuation of the 18.1a notes. I'm hoping that you took time between my part 1 notes and my part 2 notes to watch this thing here. The video that talks about exactly what a radian means. If you didn't, that's okay. I'm going to talk it real quick, but they had much better animation to show what was going on. Basically, we've been talking about angles in degrees. We're going to talk about angles in radians. If you took the radius of this circle and you carried it up and put it right here, the angle that exactly matches to the edge of that, where this is the radius and this is the radius and this is the radius, the angle right here that exactly matches to that is called a radian, 1 radian. And I could do that and take the radius again, and take the radius again, and it fits 1, 2, 3, and a little bit. You might guess that that little bit is just enough to make it turn out to be 3.1415927. I don't know the rest, but basically it's talking about all the way from here to here is the distance of pi, and so that would be a pi angle. It's 180 degrees, but it's also a pi angle. Basically what we're talking about here is, if you knew the formula for the circumference of a circle, the distance around a circle, it's 2 times pi times the radius. We're going to be dealing with what we call a unit circle, and a unit circle means that my radius is 1. And that's what we're going to be dealing with most of the rest of this chapter. Not all of this, but most of the rest of this chapter is going to be dealing with the radius of 1, which means the distance around a circle is 2 pi. And 2 pi radians would mean, if I go over to here, I'm at pi, start at 0, come back again, and I'm at 2 pi. So a full circle is 360 degrees. A full circle is also 2 pi. So that means a half circle is 180 degrees, and a half circle is pi. I know that way back when, you probably did problems where they said 18 inches equals how many feet? One way to do that is to say 18 inches over 1, and if you know that 12 feet equals 1 foot, you could say, I need to get rid of the inches. I'm putting the inches on the bottom. Oh my goodness. 12 inches equals 1 foot. I think I wrote 12 feet equals 1 foot. I could put those 12 inches on the bottom. I could put my 1 foot up on top. I've really multiplied by 1 because 1 foot and 12 inches are the same thing. So I'm not changing the value of this. And then I could say, oh, cross out my inches. My answer will now be the feet I'm looking for. What goes into the top and the bottom? I'd say 6 goes in there twice, 6 goes in there 3 times, 3 halves. So 18 inches equals 3 halves of a foot, or 1.5 foot. I'm sure you've done some of that before. That's something that is taught in much earlier math, and they do things like that in science class when they're doing conversions. I'm sure you've seen that before. What we're going to do is we're going to make a fraction that's equal to 1 so that we can use it to do our conversions. I could have done 360 over 2 pi because that is equal to 1. But why use a fraction like that when I can use a reduced fraction? I'm going to say if I have 2 pi over 3, and that's a radian measure. Radian measures always have the pi, well, almost always have the pi in them, and we're going to be trying to get rid of the pi. So if I want to get rid of pi, I will put pi on the bottom. I'll put 180 degrees up on top, and then I will work on how do I reduce that. I could multiply it all across and get 360 over 3 pi and reduce it from there. But most people find it easier to do this. The pies can cancel. Oops. This would have had a pie in it too, wouldn't it? That I would have to get rid of later. I tend to just say, we can get rid of the pies right away. And then I maybe know 3 goes in here once. 3 goes into 18 6 times, so it goes in there 60 times. I end up with 2 times 60 is 120. The pies are all gone. 120 degrees. Didn't matter if I showed this middle step, 360 divided by 3 was 120, or if I cross-canceled in the first place. Both work. If you're trying to do it in your calculator, I recommend you cross out the pies and then work the rest of it. Because your calculator will do the job for you, but most calculators, they're going to change it to crazy decimal along the way and it's going to just get confusing. So I wouldn't bother with the pies. What if I had 7 pi? We know that a full circle is 2 pi. So 7 pi would have to be 2 pi. 2 more pi makes 4 pi. 2 more pi makes 6 pi. 1 more pi would bring me to there. And that's what it would look like if I was drawing that angle. I'm going to say that this is 7 pi. I want to get rid of the pi. I'm making this a fraction. I'm going to use 180 over pi. In this case, I'm getting rid of my pies. And there's nothing else I really can get rid of. So I'm going to do 7 times 180, 1,260 degrees. If you can just remember what your fraction is you're multiplying by, those are pretty easy. I'm going to get rid of this. I don't really like having that equal sign inside my box because it almost made it look like that was negative 120 degrees, which it was not. There will be some negative ones that we have to convert in our homework. It works the same. Just throw the negative on the end of it. Sorry, in the front of your answer. These are problems where I'm starting with degrees and I want to get rid of the degrees. Since I want to get rid of the degree symbol, I'm going to put the degree symbol on the bottom. So I'm going to call this 390 degrees over 1. I want to get rid of the degrees, so I put 180 degrees down here and pi up here. The point this time is to get rid of the degree symbol and still have pi as part of my answer. So I throw the pi over there, and then I use my calculator maybe to reduce the rest of it. I'm going to say, 10 goes in here 18 times. I like it when there's a 0 on the end. I can cross 1 0 off of each. That's just dividing by 10. What else? I think 3 can go into here. So let me try it with a 3. 3 goes into here 6 times. 3 goes into there 13 times. Can I reduce 13 and 6? I don't think I can. So on the top I have 13 in pi. On the bottom I have 6. And that's my answer. Easy conversion. Easy. Just remember, don't make your calculator deal with the pi because it's only going to make it worse. 720 degrees. 720 degrees over 1. Trying to get rid of degrees, so I'll put my 180 degrees on the bottom, and I'll put my pi up on top. The point here is to get rid of my degrees and leave the pi in my answer. Look, the rest, what can I reduce? 10 goes into there 72 times, 10 goes into there 180. Do you know that 18 goes into 72? Maybe you don't. Maybe what you do know is that 6 goes into both of them. That'd be a good starting place. 6 goes in here 3, and 6 times what is 72? If you know your 12 times tables, 6 goes in there 12 times. I still have 12 and 3, so I think I'm going to reduce it just a little bit more. And say 3 goes in here once, 3 goes in there 4 times, end up with 4 pi. Remember on the first page when we were doing a circle and we talked about 0 and 180 and 360? And we said always draw in the starting ray. And then we went around our circle. Well, if we went full around one time, it's 360 degrees. If we went full around a second time, we'd have 720 degrees. So my starting and my ending ray would be together there. Well, if we're thinking about radians, 0 here, single pi here, back to 2 pi. Starting ray, 1 pi, 2 pi, 3 pi, all the way back to 4 pi. I should have made that a little smaller. There we can see. I think the degree to radian conversion is one of the easiest things in this assignment. Let's look at the second page. We're going to do coterminal angles again. Remember that coterminal angles are angles that end up in the same position. They're just 360 degrees apart. Or 2 times 360, 720 degrees apart. In this case, instead of doing add or subtract 360 degrees, we're going to do add or subtract 2 pi, because 2 pi is the same thing as 360 degrees. So instead of saying plus 360, minus 360, minus 360, I'm going to do plus 2 pi. So I'm talking about 1 pi plus 2 pi is 3 pi. There is a positive angle that's coterminal to that. I need another positive one. Circle that. I need another positive one. Another positive one would be if I take that answer and add on another 2 pi. Now I have 5 pi. 2 angles, positive, coterminal to that. Let's see about getting some negatives out of here. I need to go back and start with my original pi again. And this time, subtract 2 pi. So I'm talking about 1 pi minus 2 pi, negative 1 pi. I could write it that way, or I could just write negative pi. I need another one. So I'm going to take that negative pi and subtract 2 pi. So it's negative 1 pi minus 2 pi. I have negative 3 pi. Pretty easy when you just have 2 pi or 3 pi or 56 pi or negative 2 pi. It gets a little more complicated with fractions. And again, if you want to use your calculator to deal with fractions, you can do that. But most calculators need you to leave out the pi while you're doing that. So I'm going to have to do add and subtract 2 pi. But I see that this has a 2 on the bottom, and I have a 1 on the bottom. And we know that when we add and subtract fractions, it's a whole lot easier if we can deal with common denominator first. So I need to turn this into something that has a 2 on the bottom and a pi on the top. Let's think about, if I wanted the bottom of this to turn into 2, I could do times 2, which means I'd have to do times 2 on the top, because again, I don't want to change its value, I just want to change the way it looks. Now the top of this is 4 pi over 2. So now I'm going to do add and subtract 2 pi in the form that has a common denominator. Am I writing it too small to read well? I don't want to take up all my space. Okay. So I'm starting with pi over 2. I'm going to add to that 2 pi. But this is the 2 pi I'm going to add. 4 pi over 2. I know that's 2 pi because 4 over 2 reduces to 2. So I have 1 pi over 2 plus 4 pi over 2. I have 5 pi over 2. There's a positive that's coterminal to that. I need another one. So I'm going to take that same 5 pi over 2 and I'm going to add to that a full circle, which is 2 pi over 2 in an easier form to deal with, which makes 9 pi over 2. I need some negative ones too. So it doesn't help me to start with that red one there. I need to go back and start with the original. So I'm going to go back and start with pi over 2, maybe call it 1 pi over 2, and add 2 pi in this form. Remember, this is 2 pi. It's just an easier form to work with. It didn't help me. I already did some adding. Let's get rid of that. And let's subtract it. Let's subtract 4 pi over 2. So 1 minus 4 makes this negative 3 pi over 2. And I need one more of those. So I'll start with where I left off, negative 3 pi over 2, and subtract another 2 pi. 4 pi over 2 is 2 pi. I'm always adding and subtracting a full circle because that's where I want to end up, is a full circle away back in the same spot. This turns into negative 7 pi over 2. It's fractions, but it really wasn't that much harder if you made the common denominator before you got started on the rest of this. I have one up here that is negative. So I'm going to add to it. It's going to be adding and subtracting 2 pi again. But remember that 2 pi over 1 has to turn into something with a 3 on the bottom and a pi on the top, which means I need to say, what will I need to multiply to turn the bottom into a 3? 3. And then I need the top to be multiplied by the same thing so that I'm really multiplying by 1, not changing the value, just changing the way it looks. And this becomes 6 pi over 2. So when I say add and subtract 2 pi, I'm actually going to do add and subtract 6 pi over 3. Because that is pi over 2. I'm sorry, that is 2 pi. It reduces down to 2 pi. But it's in a format that's going to be easier to work with. So I'm taking the original one. I am adding 6 pi over 3. I'm hoping to add and get the positive one. But in this case, negative 11 plus 6 well, I definitely got a coterminal angle, but it is not a positive coterminal angle. Okay, that's okay, we can work with it. Let's do negative 5 pi over 3, and I want to add on to that a full circle. I'm adding 2 pi, because 6 pi over 3 is 2 pi. And 6 plus negative 5 gives me 1 pi over 3. I don't know why I really need that 1. So I just took it away. Now, I'm supposed to find 2 positives and I'm supposed to find 2 negatives. I really found 1 positive and 1 negative. Let me keep working on getting another positive one. I start at where I left off, pi over 3, and I want to add a full circle, which is 2 pi, but we're writing it in the form that has a common denominator. Now I have 7 pi over 3. I erased that one, but for some of you it might be easier to see it that way. Okay, got myself 2 positives and only 1 negative. I haven't even tried to subtract yet. If I try to go back to the beginning and subtract a full circle, I would have a coterminal angle. But if instead I took this negative one I know, negative 5 pi over 3, and added on a full circle. Nope, I'm trying to get negative. Let's subtract a full circle. I will end up with negative 11 pi over 3. You see that I ended up with 3 different negatives. And when the textbook tells me that they want to find the 2 closest positive and the 2 closest negative, I'm looking at those 2 and saying, which one is closer? I would say negative 11 is 11. Oh. Now I have to go back. Yeah, which is closer to negative 11 pi over 3, negative 11 pi over 3. But that didn't really help me any because it's the one I started with. So even though I just did that, we're going to say that was a worthless endeavor. I already had 2 positives. I already had 2 negatives. There was no need to go on from there. Okay, one more thing. We have 1 word problem in our assignment that we really need to deal with. I want to make sure I do one of them for you. This is an application of radians to real life. It says the length of an arc equals the radius times the radian measure. So, a track coach is standing at the center of a circular track watching his runners run. He watches them run in a 120-degree arc. So I'm just going to start here and say, here's the coach. And he's got his runners running. And they're running in a 120-degree arc. And if I put it there, that's only 90. That's less than 120. So let's take that back. Let's go over here somewhere. This is not asking us for an accurate drawing. But I'm just going to make it something bigger than 90 degrees to look at. He watches them run in a 120-degree arc. And you know what? I know from this problem that I'm going to want to know the radian measure, not the degree measure. So before I even draw the rest of the picture, I'm going to take 120 degrees over 1. And I'm going to say I need to get rid of those degrees and put in a pi. The ratio I use is 1 pi over 180 degrees. Reducing, the degrees go. Divide by 10 takes that to 12. Divide by 10 takes that to 18. 6 goes in here 3 times. 6 goes in there 2 times. So I know that my radian measure is going to be 2 pi over 3. I needed that for later, just because I know what the formula is. Let me draw the rest of my picture. I'm dealing with 2 runners. Runner A is in the closest lane of the track, 200 feet away from the coach. So here's runner A. He's running close to the coach, right here, and he's running around that arc. It's a 120-degree arc, or you could say it's a 2 pi over 3. We'll be drawing angles in radians too tomorrow. Then I need to talk about runner, well, let me put a number on here. We have 200 feet away from the coach. Then I'm looking at runner B. Runner B is running in the farthest lane of the track, 220 feet away from the coach. So let me draw a picture of his run. Yeah, not real nice and curved. A real nice accurate drawing, but good enough to see what's going on. We want to know how much farther did runner B run than runner A. What I want to know is how far is this? How far is this? And which one's longer? Oh, they already told us which one's longer. They already told us that runner B has to run further. But anybody who's run track knows that's the way it goes. That's why they don't start everybody at the same place. There's a slanted start line, so they'll come out the same way. So I need to know, let's do the purple one first. Let's do A. The formula says use the radius. If this was a full circle, all the way around here, the radius of that full circle would be 200. So I'm going to use the radius of 200, and I'm going to multiply that by the radians measure of that angle. So times 2 pi over 3. I don't think 3 goes into 200. I don't think 3 goes into 2. So I'm just going to have to do 2 times 200 is 400 pi over 3. That's how far runner A went. Let's think about runner B. Runner B, I'll try and write him a little smaller so I can fit this better. How far did he, well first of all, how far from the coach was he? He was 220 feet from the coach. So the radius of his circle, if it was drawn in, would be 220. And same arc, so we still have 2 pi over 3. And again, the 3 doesn't reduce, so I'm going to end up with 440 pi over 3. If somebody said, hey, how far did you run? That doesn't make a lot of sense, does it? Oh, 400 pi over 3, what are we measuring in? Feet. That doesn't make a lot of sense. But we can work with it. We need to know how much further. We need the big one minus the small one. So we really need our 440 pi over 3. And we need to subtract our 400 pi over 3. And seriously, it's easier to do this in this form and get an accurate answer and then round off. 440 pi over 3 minus 400 pi over 3 gives me 40 pi over 3. So if somebody said, how much further did he run? 40 pi over 3. Okay. Does that mean anything to you? That's when I go to my calculator and say, let's put it in my calculator. And that wavy line means it's approximately equal. I'm going to pause while I put it in my calculator. This is 41.887 feet. The question is, how accurate do you need to be? The Mrs. Armstrong rule is, if nobody tells you otherwise, give you 2 places past the decimal. But in this case, I think we know better than that. If somebody asked you, how many feet did you run? Are you going to tell them 41.887 feet? Are you even going to tell them 41.9 feet? I think we want to say rounded to the nearest foot. Because, hey, that tells you to the nearest step anyway. Is anybody's step length less than a foot? So I'm going to say 42 feet more for, which one ran further? For B. And I'll call that my answer. In your homework, it deals with a windshield wiper, but it's still the same situation. You could draw a very similar picture. You're going to put your degree measure here. You have the inside of the windshield wiper. You have the outside of edge of the windshield wiper. If you drive a car, have you ever noticed that the outside edge of the windshield wiper always wears out faster? It's because it's doing a whole lot more work. You're going to take your degree measure and change it into radians. Take the distance from here to here. On the windshield wiper problem, that is, how far is the lower edge from the base? How far is the upper edge from the base? So the one that's in your homework is very similar to this. There's only one of them. So when I work out some problems for you, I'm not working out that one for you. You just need to come back and look at this again. It is very, very similar to this. And that's all I have for this assignment. I'll work out a few problems from the homework, but not the one that's like this.